So, energy is a property that all matter has, and that all matter can transfer to other matter to get them to move or to do work or to move themselves, like we see particles doing all the time. Now, if you think of the total energy content of a unit of matter as, let's say, the balance in a bank account, then kinetic energy would be like spending from that balance. It would be like spending from that balance in exchange to do useful work. And that's like pushing something, that's heating up a solution, that's getting electrons to flow in a controlled way, also known as electricity. Or, as in the analogy we'll look at, it's like a ball falling from your hands and down towards the ground. So that's this. After dropping a ball from a height, that ball is actively spending. It's actively spending. I'll do this in a red color. It's actively spending its energy balance as kinetic energy as it falls. So if you don't believe me, let's actually imagine how hydroelectricity works. We generate hydroelectricity from falling streams of water. And that's the same analogy as a ball moving from a higher to a lower point under the influence of gravitational fields. So, in the context of water, we could actually extract that kinetic energy by getting that water to spin a turbine. And then we could use that energy to make, for example, electrons flow through the filament of a light bulb. And so, what would that make potential energy? What is potential energy then? Well, potential energy would just be energy that's staying in our energy bank account. And that energy could be spent or released as kinetic energy, Ke. So, back to that ball example, how would you imagine that the ball got up to such a high elevation in the first place? Well, we don't normally see things just floating in the air on their own. And so the only logical explanation would be that someone, maybe you, picked up that ball. And we know that objects at rest, or at least objects with mass at rest, they tend to attract as close together as they physically can. That's just how gravity works. And so if we have our ball here, and let's say our Earth is the other body that we've depicted here, gravitational fields would interact in such a way that those two objects would get as close to each other as physically possible. So that's the ball in the ground. And so then you can imagine that you'd have to use the kinetic energy of your arms and your legs to manually pull apart the ball and the earth. And that's almost like the analogy of an elastic band. You'd have to put in effort to pull that elastic band away from its rest state and get it to stretch. And so if we drew this ball one more time just to consolidate all our knowledge, when we pull this ball away from the earth, what we're really doing is increasing its energy balance as we increase its elevation. That means the ball has more energy that it could potentially release into kinetic energy as soon as you stopped pulling it against gravity and let it go. And so we have an increase in potential energy at this state. And yet, when we release that ball back down to the earth, that potential energy actually reduces. It reduces, and the remainder gets converted into motion. That ball moves, and that's expressed as kinetic energy.